And with that, we're at the bottom of the hour, so I'll go ahead and introduce our presenter today. I hope many of you, if not all of you, know Brian Susick with Gates Air. You saw his bio in the email invitation. I've known Brian for a really long time. I think a lot of you have. I actually saw him on the Poor Mountain SBE 78 picnic last month, and we had an enjoyable conversation and nice time with everyone else. And I thought it'd be very fitting because I think we'll be the example. WCVE is looking for a replacement transmitter, and there's the consideration of having a liquid cooled transmitter. And there are many schools of thought on this, especially when it comes to power. So there has been a lively discussion and figured this would be a great presentation for everyone to join in on. And so we've got Brian who's graciously accepted. He did so on Poor Mountain. So Brian, I'm going to hand that over to you. And thank you very much for being our guest today.
Well, thank you. Thank you very much as well. And well, this presentation is going to talk about liquid-cooled FM transmitters. We will talk a little bit about what the driving force behind it, its design and implementation was. Of course, Gates Air also makes TV transmitters, and on the TV side of things, liquid cooling is very well accepted for a number of reasons. One being that TV transmitters tend to be less efficient than an FM transmitter, so they make more heat. And it just made a lot of more sense to cool them. So the main push started for designing the liquid-cooled FM product line had to do with an unfortunate event when we lost the World Trade Center. And then for a number of years, the planning process for the new World Trade Center was in place. And John Lyons, great guy, God rest his soul, he was in charge of the broadcast properties of Durst, who basically manages the World Trade Center space. He pretty much laid down the gauntlet that the World Trade Center building was going to be a super green building, and to get that certification, they really wanted to minimize the use of air conditioning and cooling of the transmitters. Of course, TV was not a problem, but FM was, and it turns out that there's very few FM. There's only two on World Trade, and they're low power, and I think one's even a translator. So, but nonetheless, other broadcasters were being faced with pressures, to reduce operating expenses. Obviously, there's the cost of operating a transmitter is typically 5 times the initial investment over its lifetime. So when you look at that, the purchase price is 20%. Sometimes another thing is deploying people to a site is costly. Some sites aren't accessed, year round because of snow and everything. Also, aging technologies, it tends to be very expensive to maintain. The parts and skill set is much harder to find. So we listened as a company to broadcasters. Another major thing is that I don't know about you, but my electric bill it doesn't seem to ever go down. It only goes up. It averages about 8.6% per year, and is projected to rise even more by the end of 2030. The other thing is that some nations internationally impose carbon taxes, and you can see the impact on the bottom line. So when we talk about total cost of ownership, there's a lot of factors that go into it beyond just purchasing or replacing a transmitter. Some of the things include, what's the cost of acquisition? While here in the U.S., our plant is in Quincy, Illinois, so you're not having to pay import duties and taxes or whatever. what financing is available. Are some groups and stations utilize leasing arrangements where they spread the payment of the acquisition costs over a number of years. We touched on building space requirements. Do you own the space or do you lease it? And if you lease it, are you charged by square footage? How do you ship to the site? What's the installation costs? Obviously, some of the tall buildings in New York City, like World Trade, there's an expense of getting the equipment, from the loading dock to the 100th floor where it's installed. And then we get into the actual operating cost, AC, power. How do you train your staff? What is your routine maintenance costs and site visits? I mean, at a remote tower site on a mountain, you probably send 2 people there just to be safe. What are the repair costs? And if you're buying an asset like a transmitter, what's its upgrade paths? So a lot of times the amplifier technology outlives the exciter technology, where, and this holds true of both radio and TV, that if you have an integrated exciter, that you then have to replace the entire transmitter, where if the exciter is separate, as a new exciter comes out with better performance specs, you can change that. What are the warranty and other factors? And another thing that's really creeping in is cybersecurity. When you have a transmitter plant that is monitored, modern transmitter plants and facilities have a lot of SNMP monitoring going on. You want to make sure that what you're installing in there isn't opening you up to a cyber attack, which can be very costly. So as we take a look at this, the typical cycle, there's the planning, the cost for planning. This might be architects and electricians. The actual purchase and acquisition cost, and then over time. And here's several years down the road, when the next best exciter comes into play, or an upgrade. Can you upgrade that asset during its lifetime? And then there's also the cost of getting rid of and recycling the transmitter. These are all factors that you need to consider in the total cost of ownership. So total cost of ownership is very important to anyone who operates a transmitter or a network. And we've kind of already touched on a lot of these things, but there's a couple of other factors down here that we really want to dive into, and that is the amount of power that the transmitter consumes. Electricity, like mentioned earlier, isn't getting cheaper. So do you have anything in there that is affecting the amount of power that it has? It could be that you have a step down transformer or a voltage regulator that were really common. How much heat load is dissipated into the room. RF system losses, and these can be very significant, particularly with long transmission line lengths. So, like here's an example of a channel 30 of 2,000 feet of 6-inch line loses 38% of the power. So you're literally warming the tower. So that's another factor to consider. So when we look at ways of increasing transmitter efficiencies, the easiest way to increase it is to obviously lower your heat load, the wasted heat, and increase the amount of RF delivered to the transmission line. So there are a couple ways that Gates Air's engineers were tasked when they go through a design process. it's great to have the latest widget or, the greatest transistor or RF design, but there's also got to be a business reason for moving to this newer technology. So one of them is, are there higher efficiencies that we can get out of an RF device or a PA module? How about higher efficiency power supplies? And we're going to touch upon that in a minute. Energy optimized cooling systems, broadband amplifiers, so that if you have multiple transmitters with multiple frequencies, you can have an output module that can be used in any of your facilities. Modular design, make it easy to repair fast. Much higher power density to make the floor space less, because as I touched on, if you're leasing space at a site, floor space is costly. And then of course, user-friendly designs, and you want to make sure that any web interface is going to be cyber secure. So initially, our team, a lot of our products got labeled with this PowerSmart design. They use this PowerSmart initiative, and so on the television side, we have the Flexiva line of transmitters that use the latest LD-MOS technology, and it's really a highly dense platform. We leveraged a lot of that technology into the FM line, utilizing the same LD-MOS, and we have very small footprints. We actually have a 10 kilowatt FM only transmitter that's air cooled that is in 5 rack units. So, keeping in line with saving space and energy. So one of the improvements that engineers quickly, and there was a lot of debate over making the jump from a linear supply over to a switching power supply. But you got to take a look at the high energy conversion efficiency. You're at 96.3% versus 84%. Most of the RF devices today are in the 48 to 60 volt range. The power supplies that we chose to use have a very high mean time between failure of 900,000 hours typically. And when you look at the number of supplies that are deployed at this point in our products, both radio and TV, it's probably north of 50 or 60,000 power supplies, and very rarely do we hear of a failure. So this is showing kind of a power chart of a typical 10 kilowatt platform, TV or radio transmitter. So it's using a linear power supply, and you can see the amount of efficiency that we pick up by switching from the big iron power supply to a switching power supply. And that impacts on the total cost of ownership of that transmitter over the lifetime. When you say you picked up 12% by just changing technology, that's a pretty significant reason for doing that. Not to mention that by using individual power supplies for each PA module, you gain a lot of redundancy. So, in a transmitter that has multiple PAs, if you lose a supply or a PA module, the overall impact on the RF output is generally minimized. Where you lose a transformer or a choke in your linear power supply, you're down to zero power. I'd rather be on the air with some power than zero power. So it was a pretty strong argument to go ahead and make the change to switching power supplies. Well, we we use a rugged LD MOS device, and each of these amplifiers is capable of 1400 watts of peak power, and it's got very high RF gain. So it's more like 24 dB of gain. And then again, you start looking at the mean time between failure, is very, very high. Um, they're a very rugged device that can tolerate extreme um, VSWRs. And as a matter of fact, if you have some time, you can look on YouTube. There's NXP actually put a video out of them vaporizing and vaporizing a strip line circuit board without damaging the RF device. So when we came up with the design for the Flexiva line, and we make it in both an air and a liquid cooled, it was keeping it as small as possible and incorporating our world-class performance and reliability and quality. We wanted a modular design to increase serviceability, ease of maintenance with IP connectivity, and make sure that it was digital ready, so that whether it does whether you're FM only today, that you do have the capability of going to HD in the future. And field serviceability was important. So the line of transmitters, and we do this in both air and liquid, is available from 50 watts all the way to 80 kilowatts. And we utilize pretty much the same design philosophy throughout. So there's basically 3 ways of cooling a transmitter site. We can take outside air and bring it in. You want to have it filtered, and then have an exhaust fan to exit that air. That's one way of doing that. Another way of doing that would obviously be a closed loop system with an air conditioning system. This, I think, is a much better. It keeps dirt and contaminants out. This technology using outside air, it can be very efficient in some locales. In other places, it can be very dangerous and damaging. I visited a few years back during repack a mountaintop site that basically had one of our TV transmitters in it, and the site was air conditioned, but at some point someone put an economizer in, which basically took outside air and blew it in. So when we walked into this building, the RF plumbing had the same patina on it as the RF plumbing going up the tower, because of the humidity and moisture that was in the environment, because it was very high mountain. It was in the clouds a lot. So when the economizer was in, it was just literally taking all that moisture and blowing it into the building. So the final way of doing cooling is a mixture of HVAC and liquid cooling, where the majority of your heat that gets generated goes out to an outdoor heat exchanger. So there's a pretty good advantage, because you need a much smaller HVAC unit. I mean, you're still going to want to climate control and keep humidity, in check. And that's something that every site needs. Let's face it, that site I was talking about, I mean, literally the doors were rusted. I mean, the racks were rusted. It almost looked like it was raining in the building. So not a good thing. So then when you start taking a look at, you know, the costs, the energy cost, obviously, of taking outside air and blowing it into the room is relatively low. Versus HVAC, and then of course liquid. Now maintenance can be very high with that for the before mentioned reasons. HVAC, it has medium maintenance. The liquid cooling is relatively low maintenance. It's medium cost of you know, similar cost because for doing the install. Site visits, you can be a little less frequent with liquid cooling. Obviously, heat, humidity control, there's none with outside air, and it's excellent. It's very filter dependent as to how much dirt there is that it's going to be bringing into your building. And you know, as far as reliability, the liquid cooled systems have proven to be extremely reliable. So the Flexiva liquid cooled transmitters, 88% of the heat gets dissipated to the liquid. Two 10 kilowatt power blocks with dual exciters fit in a single rack. So you have 20 kilowatts in a single rack. And there again, it's scalable from 10 kilowatts to 80 kilowatts. So this shows a typical power block of the air. This is actually showing the air cooled at the moment, and you can see that the PA modules have heat sinks on them. And if I push this button, we'll show you what the liquid cooled version of that PA looks like. It's very similar, except we no longer have heat sinks. We have a chiller plate. Here's the multiple power supplies. These are air cooled. And then the PA modules and IPA modules, everything in this is hot swappable. You can open this door while it's on the air. You can take these modules in and out while it's in operation. The front door on the master PA is going to have a small VGA screen on it, and we use touch kind of a trackball for navigating. And each power block has its own independent controller, in addition to an overall system controller, so that in a multi-block system, each power block can be independently put on air. So when we take a look at the PA module, we're going to start off with a typical air cooled. You can see there's two RF devices on it, and then we put the large heat sink on it. So when we do the liquid cooled, has two RF devices on it, and the difference is it's got a much smaller aluminum plate on it, which is a heat exchange, the chiller plate. These two are the connectors. They're self-sealing, triple self-sealing connectors that allow for the PA to be inserted and removed without taking the entire system off air. So, and the liquid cooled PA module weighs about 13 pounds, so it's definitely a one-person lift. This is kind of an exploded view that shows that we do quite a bit of milling and machining. There's and this chiller plate is actually made up out of two pieces of aluminum that get fusion spun welded. And fusion spin welding doesn't use any It's not a typical welding process. It was a process developed by NASA in the space program where you can put two pieces of metal together and they vibrate it at a very high frequency, and it causes enough heating that those two pieces fuse together. And that's very important when you do something like a chiller plate where you want to have a constant uh, heat transfer signature. Whereas if it was welded, you'd have you'd be introducing some different metals into that composition. Um, this is kind of an exploded view showing other things that we have to chill. So there's a four-way splitter and combiner that gets a chiller plate added to it that the glycol goes through. So if we look at the rear of a typical transmitter, it looks very similar to the air-cooled, with the exception that you have inputs and outputs for the cooling fluid. We utilize a very common cooling fluid. You can buy it at Walmart or Napa. It's called Prestone. And we use Prestone for one very good reason, is that if you think about your car's cooling system, you have an aluminum block, you may have copper or copper fins. Maybe your pump is made out of some steel with some brass. So you have all these dissimilar metals in it. And Prestone's really figured out how to minimize these interaction between these different metals that if you were to just put water in it, they don't play very nice together. Plus, it's readily available and is not a problem to recycle either. So we do still utilize a variable speed flushing fan because, while the chiller plates do a great job of capturing all the heat, they can't capture all of the heat. Some heat is still going to be dissipated into the room. So this is an actual picture. On the left-hand side, it's showing, you can see it looks very similar to the air-cooled with the exception of the hoses, which were added in this large chiller plate. With the door closed, it's the hoses for the plumbing. So this is a schematic of a typical cooling setup. So in addition to the transmitter, you're going to have this thing called a pump module. And so what the pump module does is it's responsible for circulating the coolant through the transmitter into the outdoor heat exchanger. And our pump modules are designed with two pumps in them. They run in parallel, as you can see. But a single pump will support the system. So, over time, 15, 20 years down the road, you might have a pump that gets noisy and needs to be swapped out. With this system, we can simply, there's some valves. We can, number one, tell the system to disable pump A, for example. We can turn the valves off so that we no longer have coolant flow through it, replace the pump, and then put it back in. And if you notice that this system is totally sealed, just like your automobile is a closed system. And to deal with the difference in temperature and the expansion and contraction, we do use an expansion tank. And the heat exchanger is typically mounted outside. In some places, such as World Trade, we don't actually use a heat exchanger. We connect to the building's chilled water, and World Trade actually takes that energy and uses it for heating domestic hot water and heating and cooling. So this is a picture of what a pump module looks like. And you can see there's two controllers. The pumps themselves are variable speed. So on a cold day, if it's cold outside, you probably don't need them whirling right along, where on a 100-degree day, it'll ramp up. So, and you can see in the picture here, the valves that I talked about, and then of course the expansion tank. Gates Air manufactures the heat exchanger, and believe it or not, this is the exact same unit. You can, depending on your site, you can mount it with vertical airflow or horizontal airflow. And when they're mounted with horizontal airflow and multi-cabinets, we tend to stack them on top of one another. The units have two fans in them, and the fans are controlled. You can actually, this will require some maintenance. About once a year, you're going to want to go and have the heat exchanger hose it out with just normal water pressure, not high pressure. So in order to simplify that, each fan has its own cutoff, and then to make cleaning the fins easy, there are simply 4 half-inch bolts and nuts that you loosen off, and this whole assembly drops off, and you have access to the fins. And when you turn one of the fans off, the other fan will automatically speed up to take up the load. So lots of redundancy to keep you on the air. The other thing is that these fans are specifically designed. They have a serrated edge, and I don't if you've ever been near your chillers for a typical air conditioning system that doesn't have serrated edges. The fans tend to be a little more noisy. These fans are actually very quiet, and you can easily have a conversation next to the heat exchanger while they're running, and that's important if you're if your transmitter is located in a residential area, for example, that you got some neighbors within a few hundred feet of where these are going to be mounted. They probably don't want to hear lots amount of fan noise. So the transmitter itself is going to be very efficient. It's typically 72%, and because we're offloading the majority of the heat, a typical 10 kilowatts unit's gonna put in about 1,500 BTUs of heat into the room, thus minimizing your air conditioning requirements. So when we compare a 10 kilowatt system, air cooled versus liquid cooled, over the typical lifespan of a transmitter, you can see that in a yearly, you're going to be using around 25,000 kilowatt hours for cooling versus 5,500, and so then that really equates to your amount of efficiency of that entire system goes up pretty dramatically. And this is just a typical cost of ownership that is comparing a liquid cooled fax transmitter to a air cooled, and you can see that the acquisition cost is going to be a little bit more. At 12 cents per kilowatt hour, with the added efficiency, you can see that the break-even point for recouping this additional amount is about 4.2 years down the road. And that's for a 10 kilowatt, which as you go higher in power, this tends to be much shorter. So let's talk about connectivity and if you're managing multiple transmitter sites in your network, having IP connectivity and a graphical user interface is very important. But you have to really keep in mind that that needs to be secure, and that with the convenience of being able to sit at your desktop and look at all of your transmitters remotely and see how they're operating wonderfully. You gotta pay attention to security and how secure is that. So in the Gates Air products, we utilize several layers of security, from lightweight directory access protocol to access control table and SNMP. So the transmitter can be set up with its web interface to do encryption, so that for better performance and in a secure socket. Commands from the web client to the server are definitely encrypted. However, some of the stuff that's not encrypted might be, the metering, which would be just over a normal connection. Another way of limiting access to your transmitter is creating an access control table so that it knows what IP address and net masks. So there's a number of ways that you can set up to make the transmitter IP connectivity is very secure in today's world. So that's pretty much my presentation. It's hard to believe that this was serial number 1, and it has been. It left the Quincy factory in October of 2015. So we've got a 10-year track record of the liquid cooled transmitters. So back to you, Joe.
All right, thanks very much. I've actually got a list of questions, nothing too hard. Anyone want to go first? Right. So the number one thing on my mind has always been when we're talking about maintenance, leaks. And I know you just addressed the leaks, but can you share any insight, any stories you've heard, how simple, how complicated, whatever you've dealt with?
Well, I mean,
And may I ask, where do they occur? Like, obviously not at the component level, I'm guessing.
there are some places where a leak can occur. One that is that the system being closed, you obviously do have an air bleeder, right? So, and that air bleeder is generally at the high point of the system, and that tends over time. That's an area of concern. Is to look at that air bleeder, and if you see that it's beginning to leak or showing signs that it's leaked. The other maintenance item, we talked about the heat exchanger needing to be hosed out. There are some filters in the system that do collect residual debris, and so maybe every 6 months you're going to want to tap those, check those out, particularly when the system is first put in. And as far as, leaks, um, there's, it's not as big of it's, I haven't heard of a lot of leaks,
Do you
to
know
be
what's
honest.
involved? By the way, I misspoke. I didn't mean to say component level. I meant to ask, modular level. Like I'm thinking very few, if any, leaks, compromises there.
Yeah,
But as you had stated, so then do you know, and if you don't, that's fine. The procedure for the process is we don't want to open that system unless we absolutely have to. I would imagine you have to open up the system to repair the leak, correct?
you would, yeah. But and then you would go through a recharging of the system. So in a liquid cooled system, typically when we do an install, um, the system gets turned on. The pumps get and the whole plumbing system gets flushed out with distilled water. So that's step number one. And they're going to run that for several hours and be cleaning those strainers. And then they'll drain that out and then they charge it with the antifreeze. And like you said, once it's charged, it's pretty hands off.
How much actual antifreeze is inside of a completed system once it's done, as it were?
It's a function of you know of how long the runs are. Um, so it does vary. Within the system itself, in the transmitter, it might there might be like between all the modules and everything, there might be a gallon of it in that part.
Okay.
I think a typical loop is going to have around 15 or 20 gallons, with the heat exchanger.
Gotcha. Thank you.
And are we able to, with that closed system, monitor closely? And that's kind of a loaded question because I know with our TV transmitters, which we have these Gates Air TV transmitters, there might be a little more desired on monitoring, and maybe we haven't figured out how to do that yet. But do you know for both FM and TV transmitters, how much SNMP data is available to monitor the flow?
There is you can drill into the user interface to look at the flow, the speeds of the fans, the speeds of
And it gives the flow at just about every point you'd need,
any
the,
what
the liquid flow.
liquid.
Yeah.
Yeah, you we obviously monitor the temperature and there are flow meters as well.
Okay.
So um, I think if I step back, it showed the picture. That's one of the things that's external to the PA cabinet, is an actual flow meter. So that
Okay.
if the transmitter's all of a sudden, says, hey, maybe someone's at the site and they turn off the breaker to the pump module, for example, and now all of a sudden you no longer have flow, you want to turn that power block off, before.
Mm-hmm.
So that's where that flow monitor comes in.
Hey, speaking of, just because I'm keeping an open mind and thinking of even a FM transmitter, is there ever a level of power you could operate an FM transmitter at least where you have zero flow? So let's just say the pumps fail. Is there any scenario where it's mandatory pumps transmitter off?
I'll have to get back to you on that.
No, it's okay. Just thought I'd ask.
Yeah.
Anyone else with quick?
How long would you run an air-cooled transmitter with no fan? Just out of curiosity. I think it's probably going to be the same sort of thing. But, one of the questions that I was pondering, and Brian, thank you for the presentation. We have a few liquid-cooled transmitters within our company.
Yep.
And as Michael attests, my background is with radio, and there was never really much interest among radio engineers to use liquid-cooled transmitters. But now that I've been around many of these UHF and liquid-cooled VHF transmitters, there's really it's not as scary as it seems. The system, the glycol loop, you can measure the flow anywhere in the loop because it's a series loop, and if flow stops anywhere, you'll see it anywhere. And they run under relatively low pressure. Is that right?
Yeah, it's relatively low pressure, and I was at a very high power UHF TV station in Michigan back in February. And it was very cold. It was like sub-zero, and the fans on the heat exchangers weren't even. There was one that was spinning. Most of them were off, and I mean even the pump module was. You really didn't need to move any air over it just because of the ambient temperature.
One of the points that you made, though, I think was very important, and I'd like to underline, and that's that an air-cooled system, where you dump PA heat outside and bring in makeup air, the amount of dirt that is pumped into that. I mean, when you stop and think about it, every cubic foot of air that goes out has to be replaced by clean air coming in, and it's never clean. It's full of pollen and dust and God only knows what. And I think it contributes to that special kind of dirt that we're all familiar with inside air-cooled transmitters that just you don't see in a liquid-cooled version.
Yeah.
Good point.
Yeah, and if you're in a coastal area along the ocean, I recently saw a picture of a transmitter that's not all that old, that's in a very hostile environment with salt air, and it's not only it's just going to be a matter of time because of the corrosiveness of that salt air.
Hey, I know this answer, but Brian, I'm going to ask for anyone else who might be wondering. Many of us who've been doing this for a while were told, oh yeah, those are hot swappable modules. So I'm going to ask you, and many times we've been warned after the fact, hey, with this transmitter, don't do that. It might work or it might not. So really, hot swappable, truthfully, what say you?
Yes, with a caveat, and I'll tell you the caveat, and that is that when you pull that module out and it's been operating, the coolant that's left in that chiller plate is now captive, right? The RF device is still hot, so it's dissipating heat. So if you're going to just pull it out, maybe for a couple seconds, and try to reinsert it, that's going to be hard because the Crestone has expanded. So our TV field service rep said the way around that is I know I'm going to pull PA4 out, about 10 seconds or 20 seconds before I pull PA4 out, I take the power supply out for it, which takes that module offline. It's now cooling. The coolant's flowing through it for about 30 seconds. Now you can pull that module out and put it back in relatively fast. It's only an issue if you're going to pull it out, put it on, for a quick thing, if it's going to be out for several minutes where it's going to come back down to temperature, that's not an issue. So, but they are literally hot swappable PA modules.
That was my understanding. And yeah, I remember hearing that tip. So thank you. I think that's a good one.
On hot.
Yeah.
I think in school they told us if you waited more than 10 seconds, you should wait several minutes before putting the module back in.
Yeah.
By the way, I just swapped one yesterday and it went just fine. I've never had an issue hot swapping either the power or a phase and gain module in ours.
Yeah. And how big is your transmitter?
You sold us a 72 and an 80 back in 2019.
I remember that's big. So there's 73 PA modules in it.
And that many power supplies too.
and that
We
many
got all
cars.
together between the two transmitters. We've got about 152 modules.
Wow. Dave Morgan, did you have a question?
Yeah, maybe not so much a question, but an observation about the current environment with regard to air conditioning systems and specifically refrigerants. And this is kind of what it has really spurred my interest in liquid cooled, down the road, not today, but when the time comes to invest in a new FM transmitter or more than one for various sites. Where I'm sitting right here today in the next room is our FM transmitter room, and we are replacing a compressor today, an R22 compressor that grounded out, and R22 is going bye-bye, being replaced with R422B, which doesn't have the capacity rating of R22, so you lose some tonnage. And also, apparently, 422, from what I understand from our HVAC people, is over time is corrosive to an old legacy system. So you retrofit an R22 system with 422B, well, it's not going to have the lifespan of the old R22, and we don't have to get into why the government has decided that it's so important to take refrigerants that work well and are reliable and efficient and do away with them. We don't have to have that discussion, but here we are. And so it seems to me that it's really changed the equation of cooling a transmitter room. And so it really makes a solution like a liquid cooling a lot more attractive. And so I think you might want to look at that as part of your sales research, let's say, because that's hitting us today.
Yes.
Now I don't want to replace an HT35 today. We're replacing an AC compressor, and the HT35. And where's some wood? Well, here's some fake wood. It's doing great. Here's some wood over here. It's doing great. And hopefully it's got a lot of years of life left in it. But, say, for example, if we have a game-changing situation where we need to replace that or HT35, I really would be looking at a liquid-cooled solution simply because of the difficulties now with AC systems and refrigerants. And apparently, I guess once, down the road, 422B is going to go away. And it's who can keep up with the changes in refrigerants and AC systems? The commercial type that we use are not cheap.
No.
And so when you had up there the chart with the difference in cost, well, there's also the difference in cost. Factor in having to put in a large tonnage AC system.
Yep.
And whereas, if you can really remove most of that heat load through liquid cooling and Prestone, to me, that makes a hell of a lot of sense moving forward. And so it just, I wanted to bring that up because that's, to me, that's the biggest attractive selling point of liquid cooled transmitters these days. The others are great, but just practically speaking, one of my biggest headaches, and I know probably everybody else on this call has the same or similar issues, is air conditioning is one of our biggest pains in the butt. If we can remove as much of that as possible, that would be a wonderful thing.
Well, and the other thing is that a lot of air conditioning systems, even if they have a cold climate rating, really don't want to operate when it's below freezing outside. And, you know, as one customer of mine, he's the director of engineering of a small group, he tracks what the reason that his engineers get dispatched to sites. And you want to take a guess what the number one reason is why they get dispatched to sites? It's not because of telco power or a failure of the transmitter. It's a failure of the cooling system. He says, head and shoulders.
Yep. All right. Any other questions? All right. Well, I had anyone out there? I had one more, but go ahead, someone.
No, I just want to say thank you all for your attention, and hope to see you soon.
Thanks. Hey, I do want to ask, copper tubes versus hose. You and I had this conversation. I had never thought about it before your transport of the liquid. What do you say?
I haven't, my grandfather was a plumber, so I learned he taught me how to plumb.
Mhm.
And I got to tell you that a copper installation that our crews do are a work of art. And we no longer recommend solder. We use the crimp connectors, very reliable, a lot more reliable probably than solder, because it's a crimp, everything's set to the same standard. It just makes for a nicer looking install, in my opinion. We do them both ways. It's up to you. And some sites definitely the copper looks really nice. And
Brian, go ahead, David.
From personal experience, our old Sigma installation, we had those gates copper, and it looked beautiful. We chose the hoses on our new installation, and I personally like the hoses. The reason is because, well, as recently as yesterday, we had to change out a transmitter line section. In our case, it's kind of tight up in the ceiling. And the nice thing about the hose is, like I was at one place where I actually had my head in between two hoses, and I couldn't do that with the pipes because pipes don't bend. But the hoses that they're using are like these really extremely heavy duty gasoline type hoses. I mean, we haven't had any issues at all with any leaks with the hoses.
Yeah, and thank you, David, for pointing that out. Is that the hose is actually, I think there's three layers of hose in it, and it is it's a petro grade hose for gasoline transfer.
I think it's also fair to point out, especially to the radio engineers, if you go the route of liquid cooled, Brian and I had this conversation, it won't be Joe and Mike installing the transmitter. It would be under their high suggestion, and it makes sense, Gates Air. I don't want to mess with, commissioning a liquid cooled transmitter. And so there's an expense there, but something to keep in mind. All right. Thank you very much, Brian. This was very enlightening. Really do appreciate it.
Thank you.